Welcome to this live lesson on the equation of a straight line. To access this lesson, I highly recommend that you have already watched these 3 lessons on my YouTube series, which is gradients from 2 points, the gradient of a straight line, and drawing lines from a table. If you haven't already seen those, watching those before this will make everything a lot easier, and I'll be talking about things that I've spoke about in particularly this lesson here, the gradient of a straight line, where if you haven't seen it, it's going to make this lesson a little bit harder to access. So if you haven't already, go and watch those. If you have, we will crack on. Today we'll be looking at the equation of a straight line. Now, we have already seen the gradient of a straight line, and what we're going to be doing today is combining our understanding of the gradient of a straight line with how does that map to the equation of a straight line. So the first thing that we should talk about is, what is a straight line? Well, obviously a straight line is one that is straight and sits on a XY axis. So this blue line here is what we would say is a straight line, and this straight line has 2 elements. The equation of the line, we say, has a gradient and has a y-intercept. So it has a gradient, which we know is how many across from the previous lesson to how many up. The change in up divided by the change in across. So we saw that m is the gradient equals up divided by across. And we went in depth at looking at different graphs and different lines and how the gradient's different for each one. But effectively, the gradient just changes the steepness of the line. And we've seen that. So one element of the equation of a straight line is the gradient, and the other element is the y-intercept. And all that means, and I'll go back to that equation in a second and explain it, but the y-intercept is where it crosses the y-axis. So we know, hopefully, that this here is the y-axis, and all we have to decide is where does this blue line, in this instance, cross the y-axis? Well, clearly it crosses the y-axis at 1. So we would say the y-intercept is 1. How does that map to the equation of a straight line? Well, I've put this in a remember me box, which would be really useful to put on a revision card because it is the fundamental equation that you need to know to do with a straight line, especially at GCSE, which is y equals mx plus c. And you should already spot something that you know there, which is m. We know that m is the gradient, and we know the gradient is the steepness of the line. The x and the y we refer to as just the x and the y coordinate. So these x values and these y values, which are unknowns at the moment, is something that we could replace with a coordinate. And the plus c on the end, this plus c here is the y-intercept. And what does that mean? Well, as I just explained, that simply means that it's where the line crosses the y-axis. So y equals mx plus c is going to be very, very important for all things to do with straight lines, from the very basics up to the most complicated topics to do with straight lines. So y equals mx plus c, if we look at this blue line here, it says y equals 2x plus 1. Well, if we map that up, which one's the gradient? M is the gradient, and m is always in front of x. Okay, and that's really important. M is always in front of x. So if we map up this equation down here, what is in front of x? 2. So that means the gradient is 2. And from prior lessons, if the gradient is 2, that means every time you go across 1, you go up 2. Across 1, up 2 to create the line. Cross 1, up 2. Cross 1, up 2. Cross 1, up 2. So the gradient here, we could look at that equation and say, look, what's in front of the x? 2. That means the gradient m is 2. And what's this plus 1 on the end? Well, that maps to plus c. And we discussed a minute ago that this line clearly crosses the y-axis at 1. So the y-intercept is 1. C is 1. And the gradient, if I draw it on, is across 1 and up 2. And remember, m equals up divided by across, which would be up is 2, across is 1, and 2 divided by 1 is just 2. And that maps very nicely with this 2 here. So we need to be able to know the form of the equation of a straight line, which is y equals mx plus c. M is the gradient, c is the y-intercept. And we need to be able to identify which one's the gradient and which one's the y-intercept. So we're going to do that in example 1. I've written loads of different equations of a line where we're going to look at what is the gradient and what is the y-intercept. So, example 1 says write down the gradient and the y-intercept of these lines. Well, if we focus on the first one, we have the equation y equals 3x plus 4. Now, I'm just going to write the equation of a straight line above. It is y equals mx plus c. You need to remember that and drill that into your memory because it will make these questions so much easier. Y equals mx plus c is the equation of a straight line. All you have to do is map this up. We need to know what the gradient and the y-intercept is. Well, what is m? Because remember, we know m stands for the gradient and we know c stands for the y-intercept. This is the y-intercept and this is the gradient. Well, this is really easy now. What's the gradient of this line? Well, what's in front of the x? 3. So the gradient is 3. And what is the y-intercept? 4. So what could we say about this line? Well, we can see that it's got a gradient of 3, which means every time you go across 1, you go up 3. And it crosses the y-axis. The y-intercept is 4, so it crosses the y-axis at 4. So that line would cross up here. And every time I went across 1, I'd have to go up 4, which is off of this graph. Okay. So really powerful. By knowing y equals mx plus c, you can look at an equation of a straight line and tell me the gradient, and you can tell me the y-intercept. And you need to link what that means. And the next lesson will be where we look at a line and we form the equation from the line. So we'll be able to get a straight line and write down what is the equation of that straight line. But today we're just going to be looking at how this equation works and how do we get m and c from it. So number 2, here is an equation of a line which is y equals minus 5x minus 10. We need to know what is m, because the question's asked us for the gradient and the y-intercept, which I'm just going to put up here. That's m, remember, and this is c. Okay. They are the letters we use to denote those. So what is m? Well, remember, m is always in front of the x. Remember, y equals mx plus c. The gradient is m, which is always in front of the x, which in this case wouldn't be 5, it would be minus 5, and that's really important. And then c is the number on the end, which in this case is, and those colours are far too similar, this case here, the c would be minus 10. So I could say that m, and a lot of questions I get from students is, oh, plus c, what does it mean if there's a minus? When we say in a generic equation like this, where we're just given the general form of it, they will always use a plus, just because it can be plus any number, okay? And if that number happens to be negative, if you do a plus negative, so let's just say RC is minus 10, what would plus minus 10 be? Well, hopefully you know that a plus and a minus would just mean minus 10, so it just change it to minus 10. So just because this is a plus c here doesn't mean c always has to be positive. It can be negative. So our m is minus 5 and our c is minus 10. What does that mean? It's very well and good saying, oh, m is minus 5 and c is minus 10, but you have to map in your head and be really confident that what does m is minus 5 mean? Well, a negative gradient means the line will be going down in that direction, okay? If the gradient is minus 5, it means every time you go across 1, you would go down 5. And these little triangles I'm drawing, if you've watched the gradient from a line lesson, will make perfect sense to you. If you haven't, go and watch it. And what does c minus 10 mean? Well, if c is minus 10, it means that it's going to cross the y-axis, remember, which is this one here, at minus 10. So if it crosses at minus 10, every time you go across 1, you have to go down 5. So the straight line would look something like that. It's really important that you can think about what does it mean if m is minus 5 and what does c is minus 10 mean. It's all well and good being able to write it down, but having that understanding of what it means is really, really important. Example 3, y equals 1/2 x. Y equals 1/2 x. Well, remember the equation of a straight line is y equals mx plus c. So we need to know what is m and what is c. Well, m is always in front of the x. That is a really important fact. M is always in front of the x. What is in front of the x here? When I say in front of, I actually mean the coefficient. And coefficient is the fancy word for in front of. So the coefficient of x is 1/2. So that means the gradient is 1/2. And we've learnt from previous lessons that 1/2 as a gradient, up divided by across. That means 1/2 means every time you go across 2, you go up 1. Across 2, you'd go up 1. Or across 1, up 1/2 is the same thing. So that's the gradient of that line. What is the plus c? Well, there isn't one. Okay, there isn't a plus c. So what does that mean? Where does that cross the y-axis? Well, if there is no c value, if there is no plus c, it means it crosses the y-axis at 0. Okay, so that means the y-intercept is 0 because they haven't written one down. Let's think about what that means. We've established the gradient is going across 2 up 1, or across 1 up 1/2. It's exactly the same thing. What does a c equals 0 mean? Well, if you look at this line over here, this line is crossing the y-axis at 1. If c is 0, it means that it would cross at 0. So it just crossed there, look. This bit here. So I've just moved that line. It would cross here at the origin is another word that we call 0 on a y and x axis. At the origin, it crosses at 0. So if there is no y-intercept, if there is no c on the end, it means that it crosses at 0. Number 4. Y equals 8 minus 3x. Now, a really common mistake here is this. A student would write m equals 8 and c equals minus 3. And hopefully you can see why that is wrong. That is completely wrong. And they only do that because they're so used to the gradient being first. They're so used to the gradient being here and then the y-intercept being here. Because what is the equation of a straight line? Y equals mx plus c. In the general form of the equation of a straight line, this is a really interesting talking point here. Mx is first, always. Okay? So if mx is first, they just think, oh, the gradient's always first. However, we should know that we could swap those around. If we swap the c and the mx around, it still means the same thing. It's just written differently. You should be very, very aware that 2 plus 3 is 5, and 3 plus 2 is also 5. So even though those two numbers are the opposite way round, you get the same answer. Because addition is commutative. It doesn't matter which way you do it, you get the same answer. So look at this. I've just switched those around. That's the same thing. I'm just going to switch them back because we're used to writing mx plus c. So y equals mx plus c is the equation of a straight line. Remember, m is always in front of x, the coefficient of x. So what is in front of the x in this equation? It's not 8, definitely not 8. It's going to be this minus 3. And remember, that minus is attached to that 3. This minus is not floating around in this equation. It is attached to this 3. It's part of this 3. It's minus 3, not 3. So, yes, Ethan, you do need to do this. If the m is minus 3, we've established that m is minus 3. The gradient is minus 3. Every time you go across 1, you would go down 3. We just need to write down the c value. Well, c is the other number that is knocking around in the equation. So c must be this one. Because if this is m, The only other thing in the equation of a straight line is c, so 8 must be c. Okay, this 8 here must be c. So, c is 8. What does that mean? What does it mean that the c is 8? Well, what is c? C is the notation for the y-intercept, so that means this equation crosses the y-axis down here, up here at positive 8. Crosses at 8. And then the gradient would mean across 1, down 3. So it would look something like that. And we're going to get into sketching lines from the equation of a straight line. We're going to look at straight lines and the opposite, where we have to write the equation down. But today, all I need you to do is be able to understand mx plus c, m is the gradient, and c is the y-intercept. And link that to what it actually means. Not just, I can say what it is, what does it actually mean? Really important. So that takes us on number 5. Number 5 says 2y equals 8x plus 4. Now, if we need to know the m and the c, this is a common mistake. Students would write m equals 8 and c is 4. Because, m is always in front of the x and c is the bit that's left over. So m is 8 and c is 4. This is wrong. Because, what is the equation of a straight line? The equation of a straight line, remember, is y equals mx plus c. Does this say y equals 8x plus 4? No. If this 2 wasn't here, m would be 8 and c would be 4. However, this is 2y. Our equation of a straight line does not say 2y. It says y equals. So we need to manipulate this to get y as the subject. This 2y, we need just y equals. How are we going to get rid of that 2? How are we going to get rid of that 2? Well, think of solving an equation. How would you solve an equation? How would you get rid of a 2y? How would you rearrange to make it the subject? To get rid of a 2 times y, you would divide by 2. So, we are going to do exactly that. We're going to divide both sides by 2, because that will get rid of this 2y. What is 2y divided by 2? Just y, which is perfect. So that would leave me with y equals. And then we've got to divide all of this by 2 as well. Remember how straight lines work, solving equations work. Y equals 4x. 8x divided by 2 is 4x. 4 divided by 2 is 2. Now we have our equation of a straight line in the correct form. It says y equals. Now we can map it up. What's m? M is always in front of the x, the coefficient of x. What's c? C is the bit in the end. Okay. So our c is plus 2. So we could say that m is 4 and c is 2. What does that mean? Well, if the gradient is 4, if m is 4, remember m is the gradient, that means across 1 up 4. And if the y-intercept is 2, if c is 2, that means it crosses the y-axis, which remember is the vertical one, at 2. So it crosses the y-axis around 2 and go across 1 up 4. So it looks something like that. So there we've had to rearrange. You've had to make sure it says y equals, and that's really, really key. If it doesn't say y equals, you can't just pick m and c from there. Like, that's not correct. What I did at the beginning to show I was incorrect, you cannot do. So number 6, very similar. We need to know what is m and what is c is what we're looking for, m and c. Now, is this in the form y equals? Well, no, it says 3y equals. I need y equals. Remember, y equals mx plus c. This says 3y equals. So the first thing that we need to do is divide both sides by 3, because we need to get rid of that 3. So let's divide both sides by 3. What would that give us? That would give us y, perfect, equals 15 divided by 3 is 5, minus 4x divided by 3. Does 3 go into 4? No, not whole. So be really confident, leave it as a fraction. 4 over 3x. We've divided this 4 by 3, okay? You could work it out as a decimal, but there's no point. You may as well just write it as a fraction. Okay, and when you're doing gradients, fractional gradients are a lot easier, and you should be using fractional gradients. So now we can actually answer the question, what is m? M is going to be, remember, what is m? M is always in front of, the gradient is always in front of x. What's in front of x? What's the coefficient of x here? This one, minus 4/3. So the gradient is minus 4/3. What does that mean? That means that it's going to be going down because it's negative. And it also means every time you go across, remember up divided by across is the gradient. Every time you go across 3, you're going to go down 4, is what this is saying. Across 3, down 4, because it's a negative gradient. What is the c? Well, c must be, and again, this is another one where they've tried to trick you by putting it in the other order, where c is first and the gradient is second. C must be this one. C must be 5. That's my c. So c is 5. So what does that mean? If c is 5, that means the y-intercept is 5, which means it crosses the y-axis at 5. So roughly there. Okay. So that is an overview of how do we have an equation of a straight line. We need to, what was the most important factor there? What was the biggest takeaway from that exercise? It was that we remembered this. Yeah, if you don't remember, that's game over, you can't do it. And you also know m is always in front of the x, the gradient is always in front of the x, and the c is the number left over. And also, what have we seen? We've seen that it has to be y equals. If it doesn't say y equals, you have to make it say y equals by rearranging the subject. And we saw that in example 6 and in example 5. You had to rearrange to make it the subject. Okay, so what we're going to do now, we're going to look at how do we write down the equation of a straight line given the gradient and given the y-intercept. So we have to write the equation. We're not doing what we just did. We're now doing the opposite, where we're writing the equation down. So example 2, write down the equation of the line that has, number 1, the gradient of 1 and a y-intercept of 6. A gradient of 1 and a y-intercept of 6. Well, the first thing that we need to always write down, anytime you're doing the equation of a straight line, just write down y equals mx plus c. Write it down like a robot every single time you are doing this type of question. Well, we just have to fill it in now. What's the gradient? The gradient is m, remember? So you need to know that. The gradient is m. And the y-intercept is c. So what does that tell us? Well, it tells us that the equation of this line would be y equals m, which they've told us is 1, the gradient is 1, and x, always there, mx, plus c, what's the y-intercept here? 6, plus 6. So they've told us that the gradient is 1, so it's y equals 1x, and the y-intercept is 6, plus 6. What does that mean about that graph? It means that it crosses the y-axis at 6, and the gradient is across 1, up 1. So that's that one done. Next one. What is the y-intercept of 4/3 and the negative gradient of 18? What is that as the equation? Well, always y equals mx plus c. Write it down. All we've got to do now is fill it in. What's it telling us the gradient is? a negative, got to be careful here the way they've worded it, a negative gradient of 18 and a y-intercept of 4/3, sorry. Well, let's just fill it in. Y equals m. What is m? The gradient is a negative 18. So we have to write negative 18x. What is the y-intercept? Well, it says the y-intercept is 4/3. So I literally just type, and it's obviously a positive because there's no negative, so plus 4/3. What does that mean? It means it crosses the y-axis at this 4/3, and it has a negative going down gradient of 18, so across 1, down 18. Quite a steep negative line that crosses at a fraction 4/3. Okay. Next one. We need to write down the equation of a straight line. Remember, y equals every time mx plus c. Write it down. The more you write this equation down, the more it's going to stick in your head. What's the gradient? The gradient is 7. And this is interesting. Passes through. So it says this line is passing through the origin. So we'll talk about that. What's the first thing we should write down? Y equals the origin. What does that mean? Well, we saw that earlier. A line that passes through the origin. If I move this line here, look. The origin, remember, is here. A line that passes through the origin. What number is the origin? 0. So if it passes through the origin, what's it saying? That C must be, and we'll make this note, if it passes through the origin, that means that it passes through 0. The origin is 0. So what's my plus C? Plus 0. Is there any point of writing plus 0? No, there's no point, is there? There's no point putting plus 0. So we leave the y-intercept blank. If it's passing through the origin, it means it's passing through 0, which means we don't need to write anything down for the y-intercept. So the equation of that line there, for example, 3, is simply y equals 7x. If it passes through the origin, it's passing through 0, which there is absolutely no point. You could write plus 0, but it means, not writing it means exactly the same thing. And it looks very odd to write plus 0. So we just leave it as y equals 7x. Okay. Number 4. We need the equation of a straight line that has a gradient of -2 and is passing through 0, -1. So we'll talk about that next bit. Let's just, as always, we're just going to bang out y equals mx plus c. Do we know what m is? Yes, we do. We could say that this is y equals the gradient of -2x. What's the plus c? Well, it says it's passing through 0, -1. Well, where would that be? Sorry, 0, 1, not -1. 0, 1. Where would that be on a graph? Well, if we just go and look at our graph over here, what I might just do is just clear out this stuff for a second, just so it's not distracting us. If I've got a line that passes through 0, -1, well, where is 0, -1? 0 on the x, -1. If I need to plot 0, -1, 0, 1, it's going to be here. So what's that telling us? Well, that's on the y-axis, isn't it? 0, 1 is on the y-axis because you go across nothing and you go up 1, so it's there. What would 0, 2 be? It'd be across 0, up 2. So that would also be the y-intercept. So 0, 1 is basically saying the y-intercept is 1 because 0, 1 is on the y-axis. And if it's on the y-axis, it must mean it's the y-intercept. So let's pull that stuff back. Right, so this is saying to us, and we'll make this note, this is saying that is the y-intercept. That 1 is the y-intercept because x is 0. Whenever x is 0, the y-intercept must be the value that they've put here for y. So our y-intercept here is plus 2. Okay. Last one. We need the equation of a line that has a gradient of 2/3 and passes through the point 0, 4. Well, I think we have lost the connection to the iPad, so you might have just missed some of that. I'll just flick it back on. Hopefully this will sort it out. I believe you might have it frozen. Hopefully it's okay. Right. So you might have just missed. Yours is frozen. You might have just missed a few things. If I get that back to where I think it froze from, what we're saying is, I'll just recap this bit here. The iPad lost connection. So the gradient of -2, we've put in minus 2x, passing through 0, 1. Okay? Passing through 0, 1. Well, 0, 1, we just saw on the graph that 0, 1 would be 1 on the y-axis. Yeah, it'd be here. It wouldn't be on the x at all because you're going across 0. It'd be 1. So we can say that 0, 1 basically means the y-intercept. So the y-intercept here would be 1. Okay, the y-intercept would be 1. And I'll recap that for the next one, just because that might have been a bit confusing that I was talking and the screen was frozen. Let's look at number 5. The gradient of 2/3 passing through 0 minus 4. Well, as always, we'll just bang out y equals mx plus c. And we'll fill it in. Y equals m, which is 2/3 x. Because if the gradient is 2/3, we know that means it's m, and that's always in front of x. Plus c, well, it's saying it passes through 0 minus 4. Well, if I had a axis, what would 0 minus 4 be? Well, across 0 down to -4 would be there. And if that's the point, what does that mean? If it's passing through that point, it means that must be the y-intercept. So again, we could say that this must be the y-intercept, which is c. Okay, so our plus c, in this case, is not plus, it's going to be -4. Which takes us quite nicely onto this remember me right at the bottom. This is really crucial that students always forget. If you have a coordinate of 0 and c, like any number, if you have any number here, which I've called c because we know c is the y-intercept, we can say this. A coordinate where x is 0, so whenever x is 0, will always be the y-intercept. So if I had 0, 5, what's the y-intercept? C would be 5. If I had 0, 10, c would be 10, because if x is 0, the y part of that coordinate will always be the y-intercept. If I had 0, -3, well, because x is 0, think of a graph. What's the point 0, -3? Well, across 0, stay where I am, down -3, there. That is on the y-axis there. So whenever x is 0, the y part will always be c, what we call the y-intercept. And we've seen that here in these examples. Look, what is the x value for these? 0. Whenever x is 0, the bit that comes after for y will always be the y-intercept. And that's a really, really important fact. Okay. So, the remember me's, this one here and the main one on the front page. Really important, put it on the revision card. There's your takeaway. Y equals mx plus c. M is the gradient, c is the y-intercept, which is where it crosses the y-axis. In the next part of this lesson, in straight lines 2, we'll be looking at how do we look at a straight line and write down y equals mx plus c for it. Okay, thank you for joining in. Hopefully you learned something. And as always, in the description, there will be plenty of questions that you can practice and mark for yourself. So I highly recommend, once this ends, have a look at those questions in the description, have a go, mark them, and if there's any issues, just drop me a comment. See you in the next one.